So you would say, okay, find a polynomial in standard form with rational coefficients with these given zeros. So you would write out, okay, if these are zeros, x equals -1, x equals -4i, and x equals what without being told? 4i. Because if you have an imaginary solution, its conjugate is also a solution. If you have an irrational solution, its conjugate is also a solution. And then we're working backwards, so it equals 0. X plus 1 equals 0. Add 4i. Okay, now also, then from there you would, so x plus 1, x plus 4i, and x minus 4i. A good way to get this one wrong is to not listen to my suggestion of we always multiply conjugates together first. So when you multiplied that out, you should have got x squared plus 16. I didn't go through y, but hopefully you're good with y. And then we have our x plus 1. So when you multiply that out, you should have got x cubed plus x squared plus 16x plus 16. How many got it right? Way to go. I did see many of you out there get it right. I saw a lot in this group. Good. Hey, let's see. Do you want to try another one? The really advanced learners? Well, this is for the really advanced learners, so we won't worry about you. Go through it. A few of you are right. So x equals 1, and x equals -1 plus 2i. What else is a solution? Make sure you don't make the tragic mistake of changing conjugate only means change a sign in between. So now we're going to work backwards using algebra. Subtract 1. So we have x minus 1 here. We're going to add 1, subtract 2i, aren't I? Look, that really adds up to be 0. So we also have x plus 1 minus 2i. Then right here, our algebra is add 1, adds 2i, add 2i. So then we have x plus 1 plus 2i. Now, when multiplying this bad boy out, I think actually you guys did quite well with not making errors on multiplying this out. Do you want me to go through it or just write down what you got? So, what'd you get? X squared? That's what you should have got if you multiplied that out correctly. But once again, guys, you understand, right, that if you make a mistake back here, writing down the root up here, your whole thing's wrong. And so then we would multiply in x minus 1. We can do it all. What would we get? Does anyone agree? Anyone else? Okay. I don't know. I'm not going through it, so I'm just waiting to hear. Anybody else get that same thing? Good? Okay. A lot of people got that. Do you guys get that? Back there? You didn't get that. Uh-oh. Is it wrong? Everybody, get out 2-7. I want you to go back and make sure that you've done those ones right. So check them off with me. But now hopefully you're seeing if you know, oh, I made this mistake on all of them, start fixing them. You don't need to erase. So a couple things we're going to quickly go over. I don't spend a lot of time teaching this because it's so straightforward that it's a dead giveaway kind of. So I'm just going to quickly go over it. Because it's on the test and on the review. Listen so that when you get there, you don't say, what is this? Because I'll say, I went over that, even though you weren't listening. So let's read this question. It's not anywhere on any of your stuff, but that's because it's a dead giveaway, easy peasy. So it says, this is what's called the remainder theorem. In the instructions on your review and test, it will say, use the remainder theorem to find P of 2 of the following polynomial. Now, even though we have no idea what this is talking about, what do you think P of 2 means to do? Insert a 2. Isn't that a dead giveaway? If you were like, I'm not really sure. Well, it looks like P of 2 might be saying plug in a 2 wherever there's an x. So then let's do it. 2 cubed minus 2 times 2 squared plus 5 times 2 minus 1. Go, calculate it. Use parentheses. So type that into your calculator. You should have got 9. Did you? Wait. So our function, when we plug in 2, equals 9. Now what that means, listen to what that means. Did you see the remainder theorem? What that means is guys, is if we take if we were to do synthetic division with 2, isn't x equal to 2? So if we did synthetic division with 2, our remainder is going to come out to be 9. So I'll show you. So we have a 1, a -2, a 5, and -1. Just watching. Drop straight down. We add straight down, multiply up. We add straight down and get multiply up. Add straight down. Times by 2. Add straight down. Do you see how my remainder is if we just plugged into? Same thing. So that's what it's saying. The remainder theorem is saying we can find the remainder by plugging into. Yes. Yeah.
Aren't these two like the same thing? Balance and 2 times 2 is just 2. Because they're not equal. Like, because like 2 times 2, wouldn't that just make that 2/3?
Oh.
Or 2/3?
Yeah, you could do that. Yeah, because that's like 1. Yeah,
You know?
good point. Way to see that. Yeah, that's one way of calculating it. I see what you're saying now. Very good thought process. Okay, awesome. Okay, try this one, because seeing it once isn't enough. Go for it. So it says, because on the test you don't want to be like, what the heck, we're not going to practice this again because it's such a dead giveaway. Use the remainder theorem to find P of 4 of the following polynomial. Isn't that basically a quick way of finding what the remainder is? Didn't we just talk about that? You can plug it in, or you can do it. What'd you get? Now on the test, what I would do, so on the test, I would do this. I would also do, don't I put in 4, divide by synthetic, -1, -3, 1. Watch, add straight down, multiply up, add straight down, multiply up, add straight down. Do you see? This is what I would do on the test. That's my remainder. Everybody good? Because they might say, so what does that mean? You'd say, well, it means that if I divide 4 by synthetic division, if I divide with 4 by synthetic division, my remainder is going to be -27. All good? Yeah. So last time we'll talk about it. Okay, let's go on to today's lesson. Today's lesson stuff is great because we already know how to do everything. Here we go. So 2-8 is the fundamental theorem of algebra, which we've already learned. We just didn't know it was called the fundamental theorem of algebra. So here is the fundamental theorem of algebra. The highest degree of a polynomial is the number of solutions you'll have. That's literally the fundamental theorem of algebra. So if I said to you, the fundamental theorem of algebra says we have how many solutions, you'd say 5. Good. Now just be careful because they'll try to trick you sometimes and do something like this. Not have it in standard form. And so a lot of people will say 5, but if there was a +6 plus x to the 6, then my solutions, the number of solutions would be 6. So just make sure it's in standard form. Next thing, the word complex solutions. It's just a vocabulary word used in math, so I'm going to explain what that is. Complex solutions are any type of solution, imaginary, irrational, or rational. So if I say to you, find the complex solutions, I just mean solve it all the way. I want any type of solution. Does that make sense? If I say to you, find the rational solutions, wouldn't that only be this type? Find the complex, that means find any. Okay, cool. Let's go to problem number 1 on the worksheet. It says, let's read the directions. Find the number of complex roots each equation will have. 8. Do 1 through 6. If you missed that one on the test, it would be sad, right? Okay. Go to number 8. Okay, let's do it. Hey, everybody, go to number 8. You guys are going to have 10 times more homework if you're going to act like this. Here we go. Number 8. It says, without using a calculator, find all of the complex roots. Doesn't that mean just solve me completely? So what I mean by without using a calculator, I'll explain in a minute, okay? So first of all, what do we know from the fundamental theorem of algebra? We will have 3 solutions. I want for you to make a bucket of solutions for all of these. So I'm going to go off to the side, make a little bucket, and then write, I should have 3 solutions. So it says find them now. Now you're going to solve by the most appropriate method. The most appropriate method would be factoring if it factors. If not, we have to use C over Q. Let's look at number 8. Can we solve this one by factoring? What method of factoring should we try? Okay, let's do it. Here we go. Pull out the greatest thing in common in this group. What would it be? So then divide by x squared. Divide by x squared. What's left in my parentheses? You're right. What's in this group? Positive 4. Divide by 4. Divide by 4. What's left in my parentheses? Now, phew, it did factor by grouping. If not, we'd have to do p over q. We'd have to start over, but it does. So we can pull out x minus 2. So then it divides out, leaving me with x squared plus 4. Now look at that. We just factored it, and now we can set our factors equal to 0 and solve. X minus 2 equals 0. X squared plus 4 equals 0. Solve for x. Using algebra. X equals 2, right? Go to your bucket of solutions. X equals 2. Right here, what should I do? Don't try to do it in your head. Just do the algebra. What? Minus 4. I want you to do all the steps. Next step. So x is equal to plus or minus 2i. Now over here, I need you to split them up today. We have x equals 2i and x equals negative 2i. Now let's count. The fundamental theorem of algebra said we should have 3 solutions. Do we? Yes, so we found them all. Pretty easy though. Like, we're not learning anything new. We're re-practicing everything we already know. Let's do another one. Here we go. Number 9. Without using a calculator, find all the complex roots. The fundamental theorem of algebra says in our bucket of solutions, we should have 3 solutions. And now we'll look at this and say, can we factor this by any method we know? Yeah, you're right. No, we can't factor it. Don't try to do what multiplies b8 times c and adds with 3b. It's not quadratic. So we do have to use p over q. You were right. We do have to use p over q. So list out, what I mean by don't use a calculator is you have to show all your work. So yes, you do need to write this out. So q, p. List out factors of p, plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, 6, 12, and then q, factors of q. 1. So wouldn't all p over q's be everything divided by 1? So can I just go like this? Our possible p over q's are these. These are our possible p over q's, but I'm not putting them in my bucket of solutions, right? I'm just circling what I listed out as p over q. Now, this would be okay to take your calculator, graph it, and look, which one should I maybe test first? That would be okay. So grab your calculator, type it in. Where should I test first? Where's it? Type it into y equals, graph it. Where does it look like it's crossing? So yeah, but what's hard about that? Yeah, so I teach my honors class that, but I don't just teach it in regular just because it's somewhat useful, but not because it's not necessarily rational. Yeah. Good point. That's yes. Okay, did you not hear me? It would be okay for you to use your calculator to kind of check where I should test first, but then you're going to show by synthetic division. So everybody, yes. Thank you. -2. So guys, what I mean is now, even though I don't want you to do second trace, find the zeros, you have to use synthetic division. So here we go. Now careful, because what am I missing in here? You're right. Awesome. So we have a 1, a 0, a -10, and a -12. Let's see if -2 is a solution. Multiply up, add straight down. Multiply up, add straight down. Multiply up, add straight down. The remainder was 0, so we can add x equals -2 to our bucket of solutions. Now understand, from here, what you would want to do, what I would want you to do is to say, okay, what I did was I took degree 3, divided by something degree 1, and got degree 2. So we have a new quadratic, x squared minus 2x minus 6 equals 0, right? Now we say to ourselves, okay, does this quadratic factor? We can continue to solve for our next 2 solutions by either factoring or quadratic formula. If it factors, won't I have 2 more rational roots? If it doesn't factor, we'll have to use quadratic formula because this one says find all the roots. What's the difference between today and yet last time? Was last time I said find the rational root. So let's say that this needs the quadratic formula. We would be done. Yeah, last time? Yeah, I said only find the rational roots. Okay, here we go. And so here we go. Does this factor? It multiplies to be -6 and adds up to be -2. 1 times 6, 3 times 2, so nothing. Here we go. Quadratic formula. X equals -b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Now, once again, remember, in my class, I would now highly recommend typing that into your calculator exactly as you see it, not trying to do it by yourself. What do we get under our radical? Just type in what's under the radical. What is it? Yep, that's right. Now remember, from there, you must not use parentheses. Then from there, we go off to the side and simplify roots 28. So we pull out a 2, root 7, right? So then we'd say x is equal to 2 plus and minus 2 root 7 all over 2. Now remember, if all three things divide by something in common, you can. So doesn't this become a 1? A 1 and a 1. So that's x is equal to 1 plus and minus root 7. So we'll go back up to our bucket of solutions. And I want you splitting them apart. X equals 1 plus root 7. And x equals 1 minus root 7. 3 solutions. We've got all 3 in our bucket. Yes?
So what if so we got like 2 by root 7 out of it. What if I'm going to
well, let's say that it depends where the negative is.
like if it's
And that would just be -1 plus and minus this root 7. If that was -2 plus and minus 2 root 7 over 2, then it would be -1 plus and minus root 7. X equals. Okay, next one. Number 14. Let's look. Okay, this is a good one. Here we go. So number 14, it says, without using a calculator, find all the complex roots. 1, 2, 3, 4, 5. It's not factoring by grouping. So we are going to have to use P over Q. Go to your bucket of solutions. There should be 5 solutions. I need you guys to focus because we're going to go quick through this one. But it's like one of the more advanced ones. Okay, here we go. So we would say, okay, let's list out all the factors of P. So here's Q, here's P. Luckily, there's not that many. Plus and minus 1, plus and minus 2, plus and minus 4. Factors of Q, plus and minus 1. P over Q, I'm just going to write it out this time. 1, 2, and 4. Now, once again, as long as you can use your calculator to see where it looks like you should be testing first. So graph that and look where it's crossing the x-axis, everybody. At a whole number place, give me 1. You only can start out with one of them. Sure, let's try -1 to begin with. Okay, let's do it. Now, here we go. 1, -3, 1, 1, 4. So we drop straight down, multiply up, right? Add straight down, multiply up, add straight down, multiply up. Uh-oh, I made an error somewhere. What? Oh, so this is a good way to catch yourself. Do you see how my remainder didn't come out 0? I'm like, what the heck? But either that's not really a solution or I've made an error. So good catch, though. You guys were able to see, oh, we forgot to write 0x. So then, oops. Oh! Okay, anyway, stay focused. Here we go, because we don't have a lot of time. We need to hurry and write 0, then 4. Okay, good news. -1 times -4 is 4. Add straight down, we get 4 times -1 is -4. We add straight down and get 0. So go to your bucket of solutions. X equals -1 is in the bucket. Now what I want you to do is not continue to go back and keep testing by synthetic division. Write out what your new polynomial is and see if you can solve that one by a method we know. So let's look. Degree 5 divided by degree 1 is degree 4, people. X to the 4th minus 4x cubed plus 5x minus 4x plus 5x squared minus 4x plus 4. Now look at this. Can we solve by any method we know still? 1, 2, 3, 4, 5. No! So So we still have to use P over Q, but you don't need to re-list them out. Look, this P over Q will be the same as these P over Qs. They have the same solutions, guys. They have the same solutions. So now what you would do is look back, don't regraph this. It's going to have the same solutions as this. Where else did it look like it was crossing? At 2? Okay, so what you're going to do, listen, do not go back and test 2 with these, but take this new polynomial that has the same solutions as this and test it with this polynomial. So we'll put a 2, put in your coefficients from this. Now why? Because look, if I take degree 4 divided by degree 1, won't it be degree 3? And then degree 3 is smaller. Do you see how we're getting closer and closer to solving this? Okay, we're making it smaller. Here we go. 1, -4, 5, -4, and 4. Let's do synthetic division, everybody. Here we go. The remainder is 0. Therefore, we can now go to our bucket of solutions. X equals 2 was a solution. Now, once again, we took degree 4 divided by degree 1. Don't we get degree? So we have x cubed minus 2x squared plus x minus 2. Well, look at that. To find the next 3 solutions, can't I solve by factoring by grouping? So let's find the last solutions by an easiest method possible, grouping. So we're going to pull out x squared. Left is x minus 2. Pull out a 1, right? 1. Don't say nothing. We pull out a 1. X minus 2. So I'll factor out x minus 2. And left is x squared plus 1. And now we can set each of those equal to 0 and solve. So set x minus 2 equal to 0. X squared plus 1 equal to 0. Solve for x. So we'd add 2. X equals 2? Yep. And then we get x is equal to plus and minus I, right? So let's go back up to our bucket of solutions. Good points, gentlemen. So we got x equals -1. Again, didn't we already have that as a solution? So we got -1, multiplicity of 2. And we got x is equal to I, and x is equal to -I. Oh, was it a 2? Yeah, that didn't feel right. Okay, so you're right. We got 2. Sorry, when I scroll up. So we got x equals 2 twice. So this is the multiplicity of 2. Now what I want you to notice is we still have 5 solutions. 1, 2, 3, 4, 5. And these solutions even make sense. Because if you look at your graph, didn't it bounce at 2? That's what an even multiplicity does, is bounce, right? So it's even making sense with our graph. All good? Okay, cool. So do problems perfect timing. So I'm going to give you some time till lunch to do 7 through 18. When you get back, we'll continue 7 through 18 for quite a while. Start solving these. Okay, so everybody, with this one, it says find all the zeros of the function. Isn't that the same instructions, just worded differently? Find the solutions, right? So once again, make a bucket of solutions. There's 3. And then once again, let's go ahead and see what method could we use. We want to not use P over Q if possible. So we could plot a 2 from the beginning, and we could factor by grouping, couldn't we? No, that's fine though. You're going to get the same answer I get. Both are correct. So shouldn't I pull out an x squared here? No, a 2x squared. Divide by 2x squared, divide by 2x squared. So then left in my parentheses is x minus 4, right? We better see if 18 pulls out. It pulls out, positive 18, divide by 18, divide by 18. Left is x minus 4. So good thing our safe haven's the same. Pull it out. So luckily, this one did not need P over Q. Let's solve it appropriately. So x minus 4 equals 0. 2x squared plus 18 equals 0. Don't try to do it in your head. Just use algebra. It is. X equals 4. There's one of our solutions. Over here, what's my first step? We should be so good at this in this class by now. Subtract 18, right? Divide by 2. So we have x squared equals -9. So x is equal to? Good. Split them up. X equals 3i. X equals -3i. We found our 3 solutions. Next one. Dear T, you guys are the best solvers of polynomials in the school. Here we go. Number 20. Well, no, I'm dead serious. Dead serious. So what should we do? What method of solving should we do here? Yeah, factor it. What should I pull out? Hey, you're right. I didn't make a bucket of solutions. You're right. Pull out a 5x. Can it magically evaporate into thin air? You got to write it. So now divide by 5x. Divide by 5x. What's left? I'm glad you didn't say minus nothing. We're way past that point at this point in the year. So now I just said that equal to 0 and that equal to 0. Solve for x. Oh. How'd you get that? So the people in the video. Okay, you're right. So x equals 0. And then right here we'll add 1. X squared equals 1. Square root, square root. X is equal to? Yep. And we have our 3 solutions in our bucket. Next problem. 22. What method should I use here? Guess what? I could use P over Q, except for a tragic mistake because it's easier to do it by a good book. Yeah, the most appropriate method would be saying, oh, this is quadratic in form. I'm going to factor this by U substitution. So let U equal x squared. This is really 9x squared squared plus 5x squared minus 4. Now look, x squared, we can replace with the U. So 9u squared plus 5u minus 4. Then you'd say, okay, now I'm going to factor that quadratic. What multiplies to be a times c and adds up to be 5. Yep, 9 times 4, which one's negative? Okay, careful though. You quick factor this, you cry, because it can't be quick factored. Drop 9u squared minus 4. Break down the middle term. You guys know how to do it. You do it. And I'll do it up here and not speak anymore. You're right. I agree 100%. My old college notebooks I can't part with because they're so important. Okay, here we go. Now, this is what we factored our u to be, right? At this point, though, this is what we'd say, but we're not dealing with u's. We're actually dealing with x squared plus 1 times 9x squared minus 4. Replace that x squared back in, and now we can solve. Yeah. Great question. So it's just getting used to recognize if it has the form x to the 4th, x squared constant, it's quadratic in form. That's the only time we use substitution. Degree 4, degree 2, constant. Just that format. So now continuing, let's see if we can solve this bad boy correctly. What's my first step? You're right. Divide by 9. Yep. And now what? Square root both sides. What's the little trick that we do? Yep. I like what he's saying. Square root them individually. Yep. 2/3. So plus and minus 2/3. I'm going to go add up my solutions back into my bucket. Did you all get the same thing? Okay, I'm gonna go back up. Didn't do my bucket, that's sad. So we got x equals I, we got x equals negative I, and we also got x equals 2/3, and we got x equals negative 2/3. So P over Q would have been way harder. In fact, other teachers decided to not teach the lesson that I taught you this day. They don't teach their students by the U substitution, they just teach them to do P over Q. So you guys have extra things to make your life easier. So what's really cool is keep in mind, remember how we were 2 days behind? We were able to catch up and teach an additional, we took 2 extra days, and I taught you an extra lesson that the other students didn't learn. So that's a lot of catch up. So good job, everybody. Last example, then the rest of the time is yours. Here we go. We would solve this, once again, we could do P over Q possibly, but the sad thing is, yeah, this is only, other students would only know how to do this by P over Q. We know a better way. How should we factor this? Good point. We can't pull out an 8. Good point. Isn't this 2 perfect cubes? Let's use our cute little trick. Cube root the front, cube root the back. Couple things to remember. You don't cube root the sign with it. So what's the cube root of 8x cubed? Not negative. 2x, right? And then this is 9, right? Cube root of 729 is 9. And now we'll do our cute little trick. You do the front times the front, then the front times the back, then the back times the back. Here we go. Front times the front. Front times the back. Don't put in your signs yet. Back times the back. Okay, let's now do the signs. If this is plus, this is, the next sign's opposite. This one's always a plus. And now look at that. We have a linear and a quadratic we can solve. 2x plus 9 equals 0. 4x squared minus 18x plus 81 equals 0. Let's solve for x. So subtract 9, divide by 2. We're just using algebra. So this would have been one of the possible rational solutions, and then we would have, anyway, we're doing it the better way. So we have x is equal to negative 9/2. And now with this quadratic, it doesn't factor. We're going to need quadratic formula. Here we go. X equals negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Did we get negative 729? Okay. Negative 9. Perfect. Did you use parentheses again? You didn't get negative 972?
Yeah, I got that.
Okay. Go off to the side. Let's do it. Break it down. It's actually not as bad as it looks, guys. So 972 breaks down into... Let's do better ones. Right? No, let's not do 2. No. Don't guess. Yes. Okay, I like that one. What? Okay, fine. 9, that's not bad. Okay, 9 and 108. Okay, 108 breaks down into... Okay, you're right. So this one wasn't bad. I liked that one. It wasn't too bad. Don't double dip. Pulling out groups of 2. So, and we pulled out an I. Don't miss that. 3 times 3 times 2. So 3 times 3 is 9. 9 times 2 is 18. I. Root 3. So this is what we're looking at. Divide all of them by 2. This becomes a 4, a 9, and a 9. So in our bucket of solutions, we also have x is equal to, I want you splitting it up, 9 plus 9i root 3 over 4, and x equals 9 minus 9i root 3 over 4. We should have 3 solutions, and we do. That is my last example. So the nice thing is, the rest of the time is yours to work. It's not anything new, and it's just re-practicing everything we've learned this unit. The rest of the time is yours. Finish the entire worksheet. It's all the same stuff. Just solving by the most appropriate method.